Okay, so the video lecture part of this is not going to be anything new. This is what we've done on our off weeks, anyways, but I know that we're in a little bit of uncharted territory because of the fact that this is something that's kind of been put out because of all the issues with what's going on right now. So the plan as of right now, what the college has communicated to us is that you guys had an extra week of spring break. And so there was nothing additional that was posted or required during that time because it was considered to be spring break. And then for the time frame of March 23rd through April 3rd, we are supposed to do everything online. And so we will have the next 2 weeks in which Mondays you will have something that is posted required for class to help us keep moving forward in the process of first semester. Um, there is the potential that things could change um, after that April 3rd date. Right now, if we don't get any further communication or any extension on the online side of things, that first Monday that we would be able to meet face to face, we would come back together and meet in our normal classroom and work through some things, get some lab activities done that we're not able to do in this sort of setup. So that's where I'm at with things right now. If you have any questions or need any further clarification on that, please let me know. I've been checking my email quite often with all of this going on, so I will get back to you and deal with those questions as quickly as I possibly can. But for right now, we are going to move forward, and I'm going to move into our bone chapter, and I will post a copy of this packet on your Blackboard. If you're able to print off a copy of it, great. If not, um, at least you have it to kind of follow along with. You can take notes on something else so that you have those available to you. And then I'm also going to be posting a copy of our next set of bone sheets. So you guys had tested out on your first set of bones, and we're moving into the second set. So we did the skull, and now we're going to get into the rest of the body. Those sheets will be posted. I would ask that you go through and label those. And then over the next couple of weeks, we will do some different items with those in working towards our test. I will say right now that testing date that was set is kind of up in the air. I want to wait and see what is fully determined before we talk about that. We are going to test over the bones. I'm just not sure what that looks like right now. So we'll play that all by ear, and I will keep you informed of the expectations surrounding that. So you have the lecture today. Packet will be posted so that you can see the information in the packet. And then you also have the label sheets, which will be posted. I'm hoping you guys are able to print those off so that you have hard copies of those. And then, like I said, we'll move forward from there. So moving into our bone chapter, the discussion on the bones, sorry, I'm just pulling it up so that I can see a copy of it. When we look at the skeleton, one of the things that people kind of fail to understand about the skeleton is that it is a living tissue. It's dynamic, it's always changing, and that's kind of a hard concept for some people to wrap their heads around, because when we think of bones, we always think of them as being very strong, very sturdy, they provide structure. And because of that strength component, a lot of times people fail to realize that it's changing all the time. It's being broken down, new cells are being added, and throughout your entire lifetime, your skeleton is really being molded and modeled. And so, if you didn't already have that notion of your skeleton and your bones being a tissue that is like your skin, like your muscle, kind of start changing your thinking, excuse me, to that understanding that it is a tissue, just like all the other tissues you guys have in your body. So when we look at the skeleton, you have a total of 206 bones that are going to make up your skeleton once you reach adulthood. And when we talk about that number 206, that's actually lower than what you have at birth. The average number around birth is, or the acceptable number, I should say, is around 300. And there's not really a definite count on that. I could ask you guys to go into or go out to the internet and look at different resources and just type in how many bones are in a baby skeleton, and you would get different answers depending on how many different websites you went to. You'd probably get that many different answers. So as long as you know in the neighborhood of 300, that puts you in a good place. By the time you reach adulthood, that number has dropped down to 206. And the reason that we see such a drop in the number of bones is because at birth you have a lot of bones that are not fused together. And once they do fuse and become one set unit, you can see over time how that number would drop down from being around that 300 mark at birth down to 206 by the time you reach adulthood. One of the biggest reasons that your bones are not fully fused is because after birth, you're going to be going through a lot of changes, growth, development, and it's important that some of those bones are not yet fused together so that you can take on that development that you need to. During the time of birth itself, you don't want the bones of the skull to be fused together. And the reason for that is there's a lot of pressure on the skull of baby as baby is coming down the birth canal. And for that reason, it's important that those bones are not set and fixed in place because that pressure could potentially cause those bones to break. So the other side of that is the pressure from the birth canal and the fact that those bones are not fused and set together. Not uncommon when you see a baby born immediately after birth that they are going to have kind of a cone-shaped head, and that is because that pressure, those bones shift under that pressure, and they get kind of a peak at the top of their head. Usually 24 or 48 hours after birth, those bones will slide back into place and you get the nice round shape that you associate with the skull. But that explains why you sometimes see that kind of point at the top of a baby's head. The last point on that first slide talks about the two divisions of the skeleton. And there's going to be a slide here a little bit later on that shows this in a little bit different way. But you have two divisions to the skeleton. You have the first one, which is known as the appendicular, and then you have the second one, which is known as the axial. Now, with the two divisions, you have a breakdown of those 206 bones. So 80 of those bones are going to be part of the axial skeleton, and 126 of those bones are found in the appendicular. The axial skeleton is named because it is on the center of the body. So all the bones that make up the axial skeleton are going to have an association with your midline. So when we look at the skull, the rib cage, the vertebral column, all of those are right down the middle, and those make up your axial skeleton. For the appendicular skeleton, appendicular comes from appendage. So these are going to be the bones that make up the outlying parts of your body, namely the arms, along with the hands, the legs, and the feet are going to be a majority of what we find within the appendicular skeleton. If you move over to the next slide, it's actually entitled Types of Bones. Bones are going to be classified based on their structure, and you have several different types of bones that are found within the body. The first one that's identified there for you, letter A, that is your long bone. And in order to be defined as a long bone, it simply has to be taller than it is wide. And if it meets that requirement, we would refer to that as being a long bone. The picture that you have there is actually of the femur. Your bones that make up your upper and lower arm, your lower leg, those would also fall into that long bone category. Then you have the short bones. And when we look at the short bones, these are going to be bones that are going to be about the same height as they are width. And if that association is fairly close between how tall the bone is and how wide it is, then it falls into the category of being a short bone. This is going to be more the bones that you guys would find in your fingers. So you have several small bones that make up your fingers and toes, and those are going to be that short bone group. Then we have the sesamoid bones. Sesamoid bones are kind of unique in the fact that they're going to be completely covered in cartilage. And wherever they're located, they're usually held in place by that connective tissue that is going to cover them. I think I said cartilage just a second ago. It is connective tissue. And that connective tissue is going to anchor that particular bone in place. Two best examples that you guys have are going to be, number one, your patella, the kneecap. So if you were to open up the knee and take a look at it, that patella is going to be completely encased in connective tissue, and that's really what helps to hold it in the location where we know it to be. The other one is a bone that some people are not as familiar with. It's called the pisiform. It's a tiny little round bone that makes up one of the 8 bones of your wrist, and it is to the outside, kind of lines up with the pinky finger, and that bone is also held in place by connective tissue. Then you have flat bones. Flat bones are going to be those bones in which one side has a nearly flat or smooth surface. And I want to point out that it is just one side of the bone because probably one of the better examples that we have here is the scapula. And the scapula, the side that lays up against your rib cage, very flat, very smooth. But the side that faces the outside has some very sharp formations on it so that muscles have a place to attach and help hold everything in place with the arm. And so it's important to understand that when we talk about flat bones, that that flat description only has to apply to one side of the bone itself. And then we have irregular bones. Irregulars are those that don't have a true specific design to them. They have projections that stick off. They kind of have random formations, and they're just very unique in their appearance and in their design. And so that would fall into the category of irregulars. The vertebrae would probably be one of the best examples of an irregular bone because there are all sorts of shapes, formations, things sticking off of the bone that would put it into that irregular category. And then the last one is the Wormian bones, also known as sutural bones. So these are located in the skull. And the reason that they're called Wormian bones or sutural bones is because in between the bones of the skull where they actually fit together, you have these zigzag like shapes on the bones. And the reason for that is from 0 to 5, the brain is going through very rapid growth, and it is going through the most growth that you will have in your entire lifetime. Now, the brain is actually able to grow at a faster rate than the bones that are there to protect it. And that creates a problem because if those bones were straight edged, every time that the brain had rapid growth, it would push those bones apart from each other. Remember, they're not fused together. It would push those bones apart from each other, and you would have several places where the brain was only going to be covered by skin and thin tissue. So the body had or has a design that allows for those bones to expand and accommodate that rapid brain growth without separating to the point that they expose the surface of the brain. So those zigzag formations, those suture lines, are kind of like interlocking teeth. And so what happens is the brain will grow very quickly and those sutures will spread apart. And they still stay interlocked to the point that they cover the brain, but they have the ability, like I said, to separate. And then as the bones catch up, they slide back together. And then you have another rapid growth, they'll separate, and then they come back together. And they will do that through that rapid growth period. Like I said, typically 0 to 5. It does vary from one person to the next. And then those bones will slowly over time start the fusion process. Now, the thing that is unique about that fusion process is it doesn't actually finish until you're in your late teens, early 20s. And in forensics, that's actually something they can use to see how old a person is how well those bones in the skull are fused together. If they are still in the process of fusing, they know that that puts them in that late teen, early 20 region. Now, with the Wormian bones, you have for each individual person has their own special Wormian lines across their bones. They look like suture lines. They are not. So they get that zigzag pattern. Like I said, they appear to be a suture. They look like it's a piece of the bone, but it's not an actual individual section of the bone. Everybody has the same number of bones, the same types of bones in their skull, but you get these different Wormian lines or suture lines that give the appearance of there being more sutures than what there actually are. There have been cases where they were mistaken for fractures of the skull, And some people, it was actually thought they were hurting their children because they could see these extra suture lines and they thought it was actually where there had been an old fracture of the skull. So if you move on to the next one, it gets into the parts of the long bone. And again, it is entitled parts of a long bone because it is specific to the long bone itself. So if you were to look at a short bone, if you were to look at an irregular, the positioning and how everything is arranged within the bone would be slightly different. So I want you to understand that this is the design that we would see within a long bone, and other bone types might have the same structures, but how they're laid out within the bone would vary. So starting with the epiphysis, and you have two types of an epiphysis on your long bone. You have a distal and a proximal. Epiphysis is a fancy way of saying end. So you have your proximal end and you have your distal end. Proximal comes from proximity, and that indicates that it is closer to the core of the body, or where the appendage would attach to the core of the body. So proximal, if we're looking at the arm, if it's closer to the shoulder, that's by your core, that would be the proximal end. If we're looking at the hand that is further away, that would be the distal end. So you can see the proximal epiphysis and the distal epiphysis. Proximal indicating the close end of the bone, distal indicating the end of the bone that is further away from the core of the body. Diaphysis, that is going to provide the length of the bone. So that is going to be that long core. And again, really where the length is going to come from within that long bone. Then you have the metaphysis, which is meta comes from middle. This is going to be kind of that transition between your epiphysis and the diaphysis. So that transition point between those two areas. The next two that we have on the list are compact bone and spongy bone. And if you find spongy bone on the picture, you'll notice that it is at the end of the bone. And if you look at where compact bone is more down into the length of the bone. Now, there's something very important here, which are the epiphyseal plates. And a lot of times people would also refer to these as growth plates. These are going to be the regions where new bone cells are produced for growth. And so those are the actual sites where new bone cells are going to originate from. And when they're first put into the bone tissue itself, they have more growing and maturing to do. And so they are spread out from each other. And that's why we call it spongy bone. You can actually see with the naked eye the holes and the gaps between the bone cells. And that's going to give them the room that they need to grow and develop over time. So that's why we want to see that separation between those bone cells so that they have the room and the space they need. Now, as we continue to put more cells in, so those epiphyseal plates are going to continue to add bone cells over time. And that's actually going to push those existing bone cells down and away. And so they will migrate from those epiphyseal plates down into the long part of the bone. And as that happens, they're also growing, they're maturing. And once they've reached their full maturation, now they're going to get pushed together and we lose that spacing. So we no longer have those holes or those gaps between the bone cells. And that's where we transition from spongy bone into compact bone. So the reason for why you have that space between the spongy bone and the compact bone is just because it's a migration. They start next to the epiphyseal plates, new cells keep coming in behind them, they get pushed down. During that migration process, they're growing, developing. By the time they fully mature, they are going to be now pushed together because they don't need to grow and take up any more additional space. The next one on the list is the articular cartilage. And articular cartilage is going to be found anywhere that two bones meet. So articular comes from articulation, and that's indicating that you have a union or a meeting of two different bones. So the articular cartilage is going to cover the ends of the bones so that as they move against each other, you don't have bone tissue that is coming in direct contact with other bone tissue. Because of how hard and sturdy bone tissue is, if it was allowed to grind against another bone, it would actually wear the bone tissue away. So you get this nice hard protective covering known as cartilage, which is going to make sure that those bones have a protective cushion between them. So you can move, allows you to glide, move freely, but you're not going to be doing any damage to the bone structure itself. From there, we have the periosteum and the endosteum. These are going to be two skin coverings that you have on the bone. Endosteum is going to be on the inside of the bone. Periosteum is going to be on the outside of the bone. Now, these two skin coverings are going to help hold material in place. When you think about the structure of the bone, we have different formations and different shapes to the bones, but the material of the bone itself is very smooth. And so it makes it very hard for nerves, blood vessels, and other structures to really have a place to grab onto. And that poses a problem because, as I mentioned very early on, bone is living tissue and it has to have a blood supply so it can get food. It has to have a blood supply to get oxygen, take away waste material. You still have to have all of that that your other body cells have as well. And so the periosteum and the endosteum are going to be these, basically they're like saran wrap, and they are going to cover the bone and help hold that material in place. So if we look at the periosteum, you can see how they've kind of peeled that away from the surface. Underneath that periosteum, so you have the bone, then you would have blood vessels and nerves, and then you would have that periosteum or that skin-like covering over the top of those blood vessels and those nerves to help hold them where they need to be so they can serve the cells of the bone. If you've ever heard of somebody having a bone bruise, what they've actually done is they have impacted the bone itself to the point where they've crushed those blood vessels that are between the periosteum and the bone. A lot of times it will happen with your heels. People run around without shoes on. Those heels hit concrete repeatedly, and you crush those blood vessels that are located underneath that periosteum. They bleed into that space underneath the periosteum. It's not a big space, and unfortunately, that blood gets trapped in there. It takes a very long time for it to get cleared out. And so a bone bruise is actually going to take a lot longer in order to heal than a typical soft tissue bruise, just because, as I mentioned, getting that blood out of there takes a little bit more time. Medullary cavity is a hollow space that you have at the core of your long bone, and it is going to be filled with yellow bone marrow. Yellow bone marrow gets its coloration because it's primarily made of fat cells, and fat has sort of a yellow tinge to it. So that will help fill that space that you have within the bone. Now we see things like the medullary cavity and sinuses within bone structure, and that's to help reduce the weight of the bone and also to give those vital structures like your blood vessels and your nerves a place to exist so that they can take care of those cells within the bone tissue itself. Now it's not in that column on the left-hand side, but if you look in the picture, there is a bracket that indicates the space where you would find red bone marrow. Red bone marrow is going to be found at the ends. So where you have the epiphyseal plates, that is where you would have that red bone marrow. And that's going to help with the new bone cells that are coming into existence. With the red marrow, the reason that it is colored red is because of the fact that it is made primarily of red blood cells. So you get that staining of red. The trabeculae, we're actually going to talk about that on another slide, and we already took care of the two types of bone marrow. Now I'm going to stop the video here. I know that's already a lot of information to digest, and I'm going to upload this. It's a lot easier to upload if the videos stay a little bit smaller. So there is going to be an additional video which you will need to watch, but I'm just trying to break this up a little bit so that I can, like I said, make it a little bit easier getting it uploaded and taken care of. So You have a week to watch this. If you want to call this a stopping point for right now, that's fine. But please understand there is another video that you will be expected to have watched prior to next Monday.